Hi everyone, so today we're going to work on graphing absolute value, the equations and graphs. So think of it as not like the open closed circle, linear line, number line idea. This is going to be different on the coordinate plane. Okay, so first of all, when we talk about our understanding of the absolute value function, there's a couple of ways you can think about it. There's the distance from zero, but this particular case is distance from y equals zero, which is the x-axis. So here's a graph of the absolute value function. And we're talking about the distance from zero. So this point is 1 unit away from zero, 2 units, 3 units, 4 units. And that's why it's going to be positive, because we're talking about 1 unit, 2, 3 units, 5 units away from the line y equals 0, which is the x-axis. Okay, so the equation is y equals the absolute value of x. Okay, so if we think about some ordered pairs that would make this true, so let's develop a table here. And I like to pick like 5 values. Let's do -2, -1, 0, 1, and 2. So if we put it in, we're going to get 2, 1, 0, 1, and 2. Notice no negative values. Again, we're talking about distance. A definition, or like separating the absolute value function into its formal definition, it would be y equals the absolute value of x is going to equal x if x is greater than or equal to 0. So basically that means that what's inside the absolute value is equal to itself. Absolute value of 4 is equal to 4 because 4 is bigger than 0. Then the other part of it is the absolute value of x is equal to the opposite of x if x is less than 0. Okay, so meaning that if the value inside the absolute value is negative, then the answer is the opposite of that. Now, what do I mean by that? So, for example, if I said the absolute value of -4, we know that answer is 4 because it's the opposite of -4, and that's what we're talking about. Okay? All right, so in our graph, there's a couple of things that we want to be aware of, that it has what is called an axis of symmetry. It is a vertical line where the graph is symmetrical on both sides. So that line happens to be the y-axis, or x equals 0. Okay, so this is the axis. Okay, it's the line that when we fold the graph over upon itself on that line, the sides match up. It's symmetrical on that line. Okay, and the vertex it's a maximum or minimum point. Okay, so over here, this is going to be our vertex right there, that corner. Okay. All right, so every graph that we're going to look at is going to have an axis of symmetry, and it's going to have a vertex. All right, so what we're going to do is we're going to graph the absolute value function on our calculators and start talking about what happens when we move it and pick it up and move it around. Now, big assumption here is that if I gave you a set of points, you can graph the absolute value by hand by putting in 2, -1, a bunch of x's and get some y's. All right, so what we're going to do is we're going to start with graphing this particular function on our calculator. So I'm going to go to y equals. Now we have to put in absolute value function. So we're going to find that in the math menu. And we are going to go to number. And it's number first one, it says ABS. Stands for absolute value. So we're going to pull that up. Notice we have our 2 vertical lines, and I'm just going to put in x. Okay, and we're going to arrow out of that. So just to make sure we understand what's going on, I'm going to press graph. And there it is. Now you can, okay, there we go. I had it set weird scale on the y. Okay, so there's my absolute value function. All right, so let's go back. Let's click done. All right, go back into y equals. I'm going to go to y sub 2, and I'm going to put in this one, the absolute value of x minus 4. So I'm going to go to math, number, ABS, x. I'm going to arrow out, and then go minus 4. Okay, so the idea here is what happened. All right, so the second one is down 4 units. Okay, so here is the graph. So I took my absolute value graph and I moved it down 4 units. So my vertex now is at 0, 4. And there it is. Okay? All right, let's try this one. Absolute value of x plus 2. Okay, so I'm going to delete these. So I'm going to go x plus 2, arrow out, press graph. Okay, so notice it went left. Now, why did it go left? Why didn't it go right? Okay, because I'm moving it 2 units, all right? And it's always opposite inside the absolute value. All right, so I'm going to move it, okay? So move it over 2 units, and everything else is the same. Okay, there we go. All right, okay. Why don't you try 3 and 4 on your own and see how you do. Okay, here we go. Here's what I got. So if I put 1/2 times the absolute value of x, I get what is called a vertical stretch, vertical compression, which means that it's pushing down on the graph and it's being wider. Okay, now it doesn't make any sense. It's a fraction. Why should it be wider? But think of it as all the x values get multiplied by 1/2, so my y values aren't as steep. Like if I do 1 times 1/2, I get 1/2 instead of 1, 1. And this one, I have -2, so notice that it's flipped over from the original, and my graph is now multiples of 2, which means it's a vertical stretch. Okay, so things that we noticed, okay, that outside it moved down, inside we moved right, this one we moved left, okay, that if we multiply by a fraction, it compressed. If I multiplied by an integer, it stretched. And the negative flipped it over the x-axis. Okay. All right, so those are the differences between the original and the change that happened. Okay. So we do have some generalizations we want to make. So we have y is equal to, we're going to call it a, absolute value of x minus k, or h, sorry, h plus k. A is your stretch compression. Okay, that's going to change whether you're straighter or fatter. Okay, H is move left to right. And K is up and down. Okay, all right, so let's try this one. All right, so 3 times the absolute value of x. Okay. Okay, notice it's more stretched to the original. So I'm going to graph the original. Okay, now I don't plot points there, I should. Okay, and then think of it as like this is over 1 up 1. Well, now it's going to be over 1 up 3 because my 1 gets multiplied by 3. And it's a mirror image. So 2 is going to go to 6 instead of 2 now. So notice the stretch. Okay. All right, let's try this one down here. Okay, so the -3 is going to flip it over. Okay, so if I graph the original. Oops, wrong way. Okay, so here's the original. All right, didn't like that. Okay, and then the -3 is going to flip it over and stretch it. So let me use that color. I'm going to flip it over and stretch it. Okay. All right, and then the 2, it says plus, which means I'm going to go left 2 units. It's always opposite. Okay, all right. All right, so let's try this guy right here. All right. All right, well, this one has an inequality sign, so and it's got a lot of changes. So let's take this step by step. All right, so according to this, I'm going to graph the original, then I'm going to stretch it by 2, and then I'm going to move it left 2 and up 4. So I'm going to graph the original. Okay, now, because it's 2 times the absolute value, I'm going to stretch it by 2 units. So it's like this one's 1, 1. Now it's going to be, I have to take my y value and multiply it by 2. So now this is going to be up here. Okay, and then because I say plus 2 and then plus 4, I'm going to move left 2 and up 4. So this blue guy is going to go left 2, up 4. Right here, and then it's going to have the same the word I want to say is slope, but it's not slope. Okay, the same stretch, the same vertical stretch. There you go, there's your final. All right, but the problem is it says greater than, which means that we have to do a test point because it's an inequality. So we're going to test 0, 0 because, again, 0, 0 is the easiest point to do. Okay, so this becomes 2 times the absolute value, 2 plus 4. So 0 is greater than or equal to 4 plus 4. So 0 is greater than or equal to 8. Well, that's false, which means don't color where 0, 0 is. So here's 0, 0. Color the other where it's not, which means color the other side, which means we're going to color inside our little V's. Okay? All right. There are a whole slew for you to try, so why don't you pause the video and try the ones on the right-hand side. I'll give you some few minutes, pause the video, and then check your work. All right, let's see how you did. Okay, so this was the first one. We picked it up and moved it right 2 and up 3. Okay, in the number 4, we multiplied by 4, and then we picked it up and moved it right 1 and up 3. Okay, and this is our inequality. So we have the original. -1 means we're going to flip it over. And then we moved it 1 right and 2 down. And then it's tested at point 0, 0. And we shaded inside. because it was less than. All right, any questions, please let me know. Have a great rest of your day, and I'll talk to you again real soon.